All right. Hey, everyone. My name is Maksim. I'm a front-end development consultant, and I'm currently working in Spotify. I work with React, TypeScript. A while ago, I wrote a book, Fullstack React and TypeScript. Maybe you read it, with my friend Alex Bispoyasov. And recently, we published a course, React TypeScript Masterclass, focusing on how to use React with TypeScript, because TypeScript is a super popular technology that allows you to feel much safer making changes to your code because it checks the semantics automatically, checks that your code makes sense, and reduces the amount of bugs in production. So today we're gonna talk about 10 typical mistakes that people do when using TypeScript with React. If you saw my YouTube channel or saw my course, you know that usually I try to do hands-on tutorials with sort of code-along format. Today is going to be a little bit different. I prepared a bunch of slides. So, starting with the most typical and most obvious, I guess a lot of you probably don't do this, but still I see it so much in the code I'm working with, that people use type any. So as you know, TypeScript allows you to assign types to variables. Usually it's done by saying your variable name, then colon, and then the type name. In this case, it's a number variable of type number. And we can assign a number to it. If we try to assign a string, we will get a type error, because string is not assignable to type number. Now, you can roughly describe a type as a collection of possible things that are similar in some way. For example, type number contains numbers 1, 2, 3, 1,000, 0.5, and you know that they all are somewhat similar. You kind of expect some sort of behavior from a number. And in real world, it can be chairs. It can be a wooden chair, plastic chair, office chair. All of them are seatable. You can sit on them. Same with numbers. You can expect that you can add, subtract, multiply them by one another. But there is also a set of operations that are not available for certain type. So for number, we can't really get a member of a number. It wouldn't make sense. So for example, if you write it like this in TypeScript, then you can sort of immediately see that something is wrong. You read this as we have a constant that has type number. We assign a number literal to it. And then we try to create another constant by getting an element by index 3 from the number. You don't expect this to work, right? But you have to think if it will work or will not. So what TypeScript allows you to do, it allows you to just write this code, and then it will check it automatically. It will say that the element that we're getting from this, it actually depends on the setting, what kind of error messages that you will get and what kind of errors will TypeScript catch for you. In this case, it just says that we're gonna get type any, which literally means it can be anything, because property 3 does not exist on type number. Sort of like if I say I drank a chair, you will instantly see that it's wrong. It does not compile in your head. Chair is not drinkable. It's not the type of things that you can drink. So TypeScript does the same. It looks at the syntax of our statements and verifies that they're correct. It doesn't have to run those statements. It can just look at the syntax and deduce that, all right, we can't really get a member of type number. There is no such thing. And it is useful because it saves you mental effort that you can spend on more important things. You don't have to think about the syntax. And your code can contain thousands of statements, and not all of them will be as trivial as numbers or chairs examples. Now, here is a very similar code snippet, but we use type any. And now things can get quite weird, because any is very, very permissive and I would say positive. It expects the best. If we say that some number has type any, now we expect that this is, I don't know, like super number with superpowers. Whatever we throw at it, we expect that it's going to be done in the most perfect and safe way possible. So if we try to go to TypeScript Playground, the code doesn't make much more sense. The only thing that we changed is the type that we provide to our sum number constant. But now we don't get an error. So you see what is the problem here, because we can continue passing around this variable what is also having type any. So type any is kind of spreading now. And that means that in more places in your code, you're not performing the type check. It sort of is viral. It spreads across your code base when you start using it. And the biggest problem with any is that, as I said, it's positive. Similar to if I say, I drank something, and you can assume that it was probably something drinkable and safe, like I drank water, or I drank tea, or lemonade. You wouldn't expect that it's brake liquid, in which case I would need immediate medical attention, right? So that's the problem with using any in your code, as it expects only the good things to happen. It doesn't expect, for example, that some number that we're trying to use here, what if we didn't assign 10 to it? What if it didn't exist at all? Or, all right, that's already wrong enough code that, okay, we assigned a numeric literal to it, and then we expect to get an element by index 3. It is already wrong, but as we assign type any to this number, we expect that, yeah, it's gonna be fine, it's gonna work. And that means that we are gonna be much more likely to get hard to catch bugs in our code, because TypeScript is not gonna tell us that something is wrong. So why do we use this type then if it's so dangerous, sort of, if it can confuse us so much? And mostly it happens because it feels convenient short term. Here are some examples. Let's say you're loading the products from some API endpoint. Thing with external sources, fetching data from your backend, loading some JSON file from the file system, or any kind of external source of information, is that often we have no way to tell what kind of object, what type of object will we get. And unfortunately, the JSON method that we're using here, by default, it has return type any. As we've already discussed, it's, let's call it a dangerous type, because it always assumes the best. It doesn't protect you from anything. Basically, by using any, you abandon whole type checking for this variable and any place where you're using this variable. So what could you do with that? The quickest workaround would be to use the type unknown. Type unknown is very similar to type any. It also expects that it can be anything. It doesn't assume anything about the form of the object that we're getting or any structure of the type. The difference is that it's not as cheerful in its assumptions. So let's look at the example. Here we have number that we forcefully assign type any to, and then number with type unknown. Now we try to assign number that is any to a string, and then we try to do the same with unknown. In case of any, we won't get any error. Any is expected to work in any conditions. TypeScript sees no problem with using it as whatever. But with unknown, we will get an error. And let's actually try this. I'm gonna copy the code. And then we go to TypeScript Playground. All right. if we look at the line number 5, type unknown is not assignable to type string. So with type unknown, you still get away with not really knowing what the actual type of your variable is, but you still get some sort of type check. It does not assume that it is one size fits all, or like it's going to work with anything. It assumes that, yeah, it is unknown. What if it doesn't work? And I think it's good that TypeScript does some additional checks and it has some safety measures for you. Same with methods. If we copy this snippet and go to TypeScript Playground, we copy them, we go to the playground, we paste it. Look, with variable or constant in our case that has type any, TypeScript doesn't see any problem calling method on it, even though we know that there is no such method on numbers. But with unknown, we get an error. Object is of type unknown, so maybe method doesn't exist on it. All right, now I'm gonna take a few moments to say hi to everyone who joined. Hey Juan from Colombia, hey Manuel, hey Juan, Jose. You're not really too late, we're just starting. I'm talking about the type any. And I think a lot of people already know that type any is not very helpful when you want to use static type checking. It basically skips all the type checks. So what I'm proposing is, instead of any, if you really have no idea what is the type you're getting, usually it happens with the types that you get from external sources. For example, you fetch them from your API. If you don't know what the type is at the moment before you make the validations, assume that it's unknown. Don't assume that it's any, because with any it won't even suggest that, oh look, method might not exist, like it happened here. Number any is of type any. Yeah, we can use method. I can add another line where I try to call something ridiculous like this method definitely does not exist. And it's fine. So it's not checking anything at all. Much better idea to use type unknown, because then it will assume that, well, okay, this method might not exist, this field might not exist. We better prevent calling it or trying to access the field. All right, so with this little recap, we can continue. If you have questions, you can don't hesitate. Just ask them in the chat. From time to time, I will switch my screen to the chat window and chat with you. All right, that's about the any. Similar mistake that people often do is people abuse type assertions. So what are type assertions? Let's say we have products. For example, we make an online store and product contains display name, cost, description, information about the product. And at some point we want to define an array of them, and initially it's empty, right? If we just leave it as is, imagine that there is no type assertion here yet. We just have let products equals empty array. By default, it will assume that the type of this array is an array of undefined. We don't want this. We want to say that this array is gonna be an array of products once we push them to it. So we say let products equals array, assume or like cast it to products array. When can we use this? So when TypeScript does not know what the correct type should be, but we know, we can tell TypeScript, all right, this is this type. Like in our example, TypeScript has no idea with an empty array what kind of objects are going to be stored in it. So we can say, look, TypeScript, it's going to be products. But when TypeScript knows the correct type, and we say, use it as whatever, as type any, then we're losing type information. TypeScript could help us, but we just prevented it. And it's a bad idea. It's similar to using any, as I mentioned before, it is infectious. It's gonna spread across your code base. Once you pass this variable to one function, then you use it in calculation in another place, and then some time passes, and then eventually some user hits a runtime error. And now, after all this time, and it's a random place in your code now, and it's some person that is filing a bug report, it's much harder to debug, it's much harder to fix, much more effort to recollect all this context that you had when you were defining this variable or constant with either type any, or you typecasted it to some unrelated type. And what often happens is that people typecast variables or constants to type any, because at the moment it was just a little bit inconvenient to follow whatever TypeScript was suggesting. Here is an example where using typecasting is kind of valid. Here we're trying to get a DOM element using query selector. As you know, TypeScript is compiled language. We take something written in TypeScript, we compile it to JavaScript. And then what is actually being executed in the browser is JavaScript, not TypeScript. And problem with this query selector is that at the point of execution, of course, we will know what kind of element did we get. We find an input of type text, and yeah, it's going to be an object of input type. We can work with it as with an input. But at the point of when we compile our application from TypeScript to JavaScript, we basically don't have this information. We just know that we called some function that can get some element from the DOM. Yeah, it has some selector, but who knows? Who knows what kind of object will we actually get? So by default, if you try to get an input with type text, you know that you're expecting an input. But TypeScript thinks that you will get a generic element. And elements in TypeScript, they don't have the value field, even though you know that input will have it. So the way you can fix it is you can typecast it to HTML input element. This type, unlike regular, base, abstract element, will have the field called value. So everything is going to be fine. The reason I'm saying that it's kind of valid way to use typecasting is because if we look at TypeScript lib.dom.d.ts, this is a file where type definitions for the DOM API are defined, you will see that query selector is an overloaded function. It means that it's defined multiple times for different kinds of arguments, and it's a generic function, which means that it has type variable. So by default, it's going to be element. That's, as you remember, exactly the type that we got as a result of calling this function. But it also means that we can just pass this, the type that we want. In our case, it's HTML input element as a type argument here. And then it will use it instead of element. Element is just the default value of this type. The default value of this type, it sounds weird, but it makes sense once you start working with type variables, where you can have variables that can have different actual values, the actual types. So for now, it's just sort of a wildcard that has default value of element. So we can override it without using typecasting. How is it done? We just pass it in triangular brackets. We use query selector. We say that we are going to expect HTML input element. Is it much better than using typecasting? Kind of. It's more idiomatic. You're really using a proper syntax for it. Is it also type safe? Not really. If you really know that you're going to get input, and in this case, I would be fairly certain that, yeah, we'll probably get either input or null, then yeah, why not? Why not either typecast it or use this thing? Good part is that if we look again at the type definition, you will see that it's going to be element or null. In our example, we just typecasted it to HTML input element with no null option. So if we would use just typecasting, we would actually be prone to a bug where this element that would be selectable by input type text, it wouldn't be found. What's then? In our code, TypeScript is not telling us that, look, input might not exist. But if you would use proper syntax in this case and use type variable, then input would be HTML input element or null. All right, do we have any questions at this point? All right. Did you ever use query selector with TypeScript? By the way, who is already writing React TypeScript code? I would like to know the experience level. All right, no questions so far from Juan. Yeah, I'm going to continue with the presentation. Let me know in the comments if you are already using React and TypeScript, and if you already found out that you did one of those things that I called mistakes here. When you refactor a React project to use TypeScript, where do you start? Good question. The short answer would be I start with setting up an interoperability mode where I allow JavaScript code to exist alongside TypeScript, and then I gradually rename. At first, I just renamed JavaScript to TypeScript. I allow type any, I allow everything. I use the softest settings possible, and then I gradually enable stricter and stricter rules, and I go gradually, maybe folder by folder, whatever is your time blocks. Like if you have big chunks of time at once, you can go in big steps. Otherwise, you can move slowly. I hope that answers your question. All right, I see a bunch of people who use React and TypeScript. Okay, we have experienced people here. Could you show what to do instead of casting in the first example with the empty array? The point with the first example is that actually you can totally cast it there. It's fine. TypeScript had no other way to know that it's gonna be products array. You could actually say products column. Let's do it in the TypeScript playground. It's gonna be quicker. So let's see, what could you do? All right, let's define product as some sort of type. Product is just empty object, whatever. There are some fields. Let's just imagine, suspend your disbelief. So what could we do here to make sure that products is an array of product? Alternatively, depending on the situation, you could probably just go like this: product array, and then we wouldn't have to do typecasting. This is also fine. I'm just expanding this example to cases where you got this value from somewhere else where it wasn't known what it is. But we'll discuss what you should actually do when you're getting some value from an unknown source, like you load it from the API, or you load it as a JSON from the file. I will show you some small example what you could do, and the real short answer would be to validate the object before you typecast or assign the type to it. If it's something unknown, just run through all the fields that you expect you're going to be using and validate that they're there. And after you're certain, like, okay, product must have ID, product must have a title, product must have a description. After you check that all of them are in place, yeah, cool, it's a usable product. We can just return it and be certain that it's a product type, and it's safe to assume that it's a product. All right, let's move on. So this is the example of query selector. Good thing about typecasting is that you cannot do these kind of outrageous things where you have two completely unrelated types, like a number and a string, and you try to cast one type to another. If you try to paste it to TypeScript playground, we'll get an error. Conversion of type number to type string may be a mistake. So that's good. Problem is that it even allows you to use a quick fix. Let's see if it add unknown conversion for non-overlapping types. Boom. Less than a second, now we have something ridiculous going on. We have a constant of type string that has an actual number as a value. So we can only hope for the best in this case. This technique of typecasting first to unknown and then to actual type sometimes might be useful. I actually used it a couple of times in my tests where I really needed to override some type, but the use cases are so rare that generally you should just avoid it until there is absolutely no other way to not use it. All right, and then what often happens is that when we have a constant that we want to assign a value and we want it to be of a certain type, and then this value came from a function argument, some place you don't control. You just got this value from the API, for example, and it doesn't match this type. So what people often do is they say value as any. And as I explained already, it's a bad idea. It's going to be spreading across your code base and causing some runtime errors at most unexpected times in worst possible manner. So what you should be doing instead, depending on your use case, you should check if the type that you're using is generic, just like with query selector. At first we thought that, yeah, it's a valid reason to use typecasting to specify that we're actually expecting the HTML input element. But really, query selector is a generic type. It has a type variable, and we could just provide it when we call this function. Another suggestion that I already gave is to perform type validations if needed, and then return the type that fits your use case. So after you know that it's a correct type, you can return it safely. Here, for example, we defined a type product or error, and then whenever we would get something unknown, data from the API, response of type unknown, we can check that response ID is undefined. If yes, then we immediately return an object that will have error, product must have ID, and product will be null. Or if title is undefined, it's also not a valid product. We don't expect that we can work with this kind of product without the title. And then we also return product null and error, product must have title. And then we can do this kind of check for all the fields. We can do more complex checks. Here I'm just looking if they're not undefined. But you could be more elaborate and validate that all the fields have the values that you expect them to be. They have the type you expect them to be, they're present, and so on. And after you've validated everything, you can just create the product type from the fields you've checked, and then return product, and now error is null. As you can see, originally we defined the product or error as a union type. And TypeScript has this neat feature called discriminated unions, where it can look at one field. For example, it can see, all right, we have product. That means that error is going to be null. Or it can see that, all right, product is null, means that error is a string, and vice versa. It can just use one field to determine what is going to be the other. And in your code base, you can now just simply rely on the type that you get from this function. Next, using tsignore directive. And before we go to the next step, let's check the comments. Will this be saved on YouTube to watch later? I'm not sure. I don't know. I hope someone from Newline could let you know. Let's see if there will be a reply. Otherwise, I might check myself somehow. I don't know. But let's continue. So using tsignore. Tsignore is a compiler directive that tells TypeScript to ignore the next line and not perform any type checks on it. The way you use it is you add a comment about the line you want to ignore during the type check. And it's also recommended to provide the reason why we are ignoring it. It's really a good idea, because once you add this at some point, then actually it applies to all sorts of comments. It's very easy to forget. Why is it commented and not removed? And same with tsignore. Why is it still in the code? Like, why did it hit the main branch with a tsignore? And here we might say, all right, here it's unreachable code block. After we discussed how important it is to not use type any or not use type assertions too much, it might be surprising that such option even exists. And thing is that it can be useful during development when, for example, we have some branching. It's a really simple code example. What it means is we had some condition and now we just want to verify that this branch will work. We temporarily provide hard-coded value Boolean true, and then here we'll get an error, unreachable code, if your TypeScript is set up like that. So what you can do is you can temporarily add tsignore comment, unreachable code, or just tsignore, it will still ignore the line, and then work with your code and then remove it. There can be other use cases as well. You might, for example, want to use it in your tests when you want to verify that invalid inputs will be handled correctly. Or you might want to use it from time to time when you're migrating to a new version of TypeScript and there is some functionality that your code is still not ready to accommodate, or you're migrating JavaScript code base to TypeScript. This is another use case where you can temporarily tsignore some lines. So there are valid reasons to use tsignore, but it's important to treat them as exceptions, to treat them with extra caution, and not use tsignore whenever you see a type error. Because what I saw in a couple of projects where people would face a slight inconvenience of some type that is, I don't know, requiring a bit too much fields from them. Instead of fixing the issue, because probably it means that the main model, the business logic is not modeled properly, where you want only a few fields and you don't have a proper type for it, something easier to use, and you always have to use something with a lot of fields that are hard to fill. So what people do is, instead of providing a proper type, they use tsignore. Bad idea, and the one way to prohibit it is to use ESLint to prohibit usage of tsignore. It can also be useful once you have a bunch of places where you have tsignore. You can enable ban tsignore rule in your ESLint config, and then it will highlight them as errors. But of course, ESLint can also be ignored for a line, code block, file, or the whole project. It's easy to trick. So be careful, don't leave tsignore comments hanging where they're not supposed to be. And we continue. Numeric enums. Here I'd like to ask you, do you use enums in your code base, and what do you use them for? Because I actually use them. I used to use them, and now I kind of stopped. Now I sort of prefer union types. What about you? Do you like enums? Not necessarily numeric enums. Maybe you like string enums. I think a lot of things about programming is just a matter of preference. For now, let's move on. So, numeric enums. TypeScript has a special type called enum. One way to describe it is to say that it's a collection of constants. So here we have a group, fruit, that has apple, banana, and orange as its members. So we have basically three namespaced by the fruit enum constants, apple, banana, and orange. What we can do now is we can say that some fruit constant has type fruit, and from now on the only values that we'll be able to assign to it are the members of the fruit enum. So all good, all type safe, nice, and we have this way of, first of all, limiting the amount of limiting the possible values to defined set, and it's very clear. You will have auto completion with your enum. There is no way you can do typo. TypeScript will check it for you, and so on. Good, great. If we try to assign apple here, a string literal containing exactly same value as we used to define our apple field, it's not going to work. Let's copy this and verify. We go to TypeScript Playground, paste it here. Nice. Even though apple is has exactly same value, it's same literal, same string literal as in the apple field, it's not gonna work. We have type error. Apple is not assignable to type fruit. And that's good. That's type safe. That allows us, that guarantees that the only values we can use with this type are its fields, because it checks not structurally. That's common notion that TypeScript has structural type checking. It doesn't care about the name of the type. It only cares about the form of the object and that it has the same fields, and then it deduces that, yeah, all right, that's the same type. Not in case of string enums. Here it actually checks the name. You can use this in React to, for example, model possible view states of your components. Let's say your component is fetching data from some API, and then it can have loading, error if you got error from the backend, and completed state when you got the data. Here is an example. I prepared a code sandbox. We'll have to zoom out. So what is happening here is we have our enum status. It has success, error, and loading state. And then along with this status state of type status, we'll also have to store the user data somewhere and the error somewhere. And then when our component mounts, we call useEffect callback that will initially set the error to null, set status to loading. Then it will wait for the user, save it into the state, set status to success. And if we got an error, we catch it in the try catch block. We set the error to this value, and then we set status to error. And it's nice because now we can check one of those three states. If it's loading, then we show the loading indicator. If it's an error, then we show the error message. And if everything is fine, we can just render our user. But can it be done better? Yes, it can. But before that, we'll discuss a bigger problem with enums. And the problem comes with numeric enums. The way to define numeric enum is just list the fields. If you don't provide the string value of those fields, by default, they're going to be numbers. And TypeScript will assign them values starting from 0 automatically. So here, if we check what is the apple member of enum, it's 0. Banana is 1. Orange is 2. We can change any of them, and we can say apple is 4. Now banana is 5. Orange is 6. So it sort of continues from the number that you set to it. So here we specify apple equals 3, means banana is going to be 4, orange is 5, and it's okay. What is not okay is that now you can literally assign any numeric value to it. It's not type safe. It does not guarantee anything. You want to have a proof? Here you go. Let's copy our enum. Let's paste it to the TypeScript playground, and well, we don't have any errors. Did you expect that? That numeric enums are not type safe at all. They're not validating that whatever you're passing is a member of this enum. There are actually articles that explain why it's done like that. I think there is actually a reason of why it works like that. But it means that if you want to be certain that the only values that can be used with your enum type are members of this enum type, then probably numeric enum is not what you should use. Oh, we have a person who had this happen before. Did it make you appreciate? Did you make it appreciate union types better, or did you just? What did you do? What were your conclusions? Did you continue using enums, but you started using string enums exclusively, or you switched to unions? Because I decided that yeah, I probably prefer union types now. And I will actually show you soon what is another reason why I prefer union types. I think they're a bit more powerful. They allow you to model some kind of situations better. So what do you do with this information? As I said, I prefer union types. We can sort of get similar benefits. We define fruit as a type, as a union type, that can be an apple, banana, or an orange. Again, it's not going to allow us to use any other value. Let's try this out. Let's go to TS Playground. The reason why we wanted to use enums is because we wanted to limit the possible values of a constant to only the fields that we define on that enum. Let's see union. It's kind of the same result. Const some fruit is going to be a fruit. And then we assign, I don't know, pineapple. Pineapple is not assignable to type fruit. Now let's try to use something that we had in this union. Apple, we even get the suggestions. And it works. So really, I don't see any reason to use enums where we can reach very, very similar result. Not exactly the same, but very similar result using union types. And there is a nice bonus. Here I'm showing basically the same as I've demonstrated using Typescript Playground, but here is a bonus. If you remember the previous example where we had loading, done, and error state, we can model similar situations, similar set of use states with union types, but we can get more benefits from it. For example, we know that when we're loading, when our application is in loading state, we won't have the user or we won't have error. Nothing exists. We just have status loading. We don't expect any other field to be populated. And it is reflected in our view state type. Now it's enough to use only one state. In our use effect, we change the status to loading, and then look what happens. If we try to set status to done, and we don't provide the user, then we already get a type error. Type done is not assignable to type error. It expects that there must be type user. If user does not exist, it thinks, okay, it probably is an error. So you get better type checks that allow you to feel safer when you write code, that you're covered. TypeScript knows that if we're done, we want to provide the user. If we have status error, we want to provide an error. And then when we check for different status values, you can rely on the other fields as well. So for example, here, when we check that the status is error, we are certain that message is defined. If we look at the type, error.message is a string. If we look at the type of, maybe not here. Yeah, here is defined as union. So it could be shown in some cases as error or undefined, but here, when we check that it exists, that the status is error, we already know that that error will exist, will be defined on that object. And I think it's super neat that we get this additional type checking. All right. Next one, marking fields as optional. All right, Raja prefers const enums most of the time. I assume const enums are the ones with string values, right? Was new to TS, just kept marching on while learning again that I didn't fully understand TS. Just learning project, probably never went back and refactored. Huh, interesting. All right, let's continue with marking fields optional. What's wrong with that? So in TypeScript, you can mark some fields of your types optional by adding question mark to them. So for example, we have a breakfast type that can have coffee, eggs, and bacon, and coffee is a required field, eggs and bacon are optional. So now we can define breakfast as an object that has only coffee defined. And sometimes it's a good idea to do this because that's exactly what you want. For example, in React, you can have some fields optional. Here we have has promotion field that is Boolean, that can be true or false, but it is also optional, which means that when we try to use this component with these props, we don't have to pass this has promotion Boolean flag. Because we know that undefined is also a falsy value, and we can render it in as a non-promotion product card if the flag wasn't passed to it. But let's say we have a job board website. On the job description page, we receive a job description type of object from the backend, and the types that we're using were generated automatically. And for some reason, you now have a bunch of optional fields. For example, it can happen with types generated from GraphQL schema. Depending on your setup, you might have a bunch of optional fields where they're not really optional. If you look at the job description, does it make sense that we have an object that has ID optional? Not likely. Probably if we get an object that represents job description and it doesn't have an ID, something is broken. Same with the title. It's unlikely that we're going to use this kind of object. So what could you do? You could just roll with it and try to implement your component. So for example, we have our job page. It got this props where we have job description prop. And then we'll have to have additional checks all across our component. So here it's very, very simple. It only has header level 1 rendering with the job description title and a paragraph with a job description field. And it's already adding a bunch of code where we have to verify, does the title exist? Does the description exist? And on top of that, how much sense does it make that we're rendering a job page without title and without description? Basically, here with this sort of code, we might even render an empty page just because we got a faulty value from our backend. A much better idea would be to create another type, validate the value that you got from the backend, return a validated object where only the non-essential fields are marked optional. So for example, for our job description, location is an optional field. Minimum and maximum salary are also optionals, but ID, title, and description must be present. So now in our layout, we can be certain that title exists, description exists, and we can just render them without any additional checks. So your code becomes more simple. It becomes easier to read. You remove the clutter. You don't have to make additional checks that, well, they don't really protect you from having broken states of your application. So if you're rendering a job page and it doesn't have neither the title nor description, how much sense for the user does it make? I don't think it's a very, very kind of useful page that has zero information. Another example, optional component props. Let's say we have a component that might receive a prop that is undefined. And sometimes people mark such props as optional. And here is the catch. If you know that your error message must receive error text and it doesn't make sense to render error message empty, you should probably make it string or undefined, to use an union type instead of making it optional, because now you can guarantee that some value will be passed to it, that you kind of make it more clear how you intend your component, or if it's a function, for example, it doesn't really matter. You provide more information about how it's supposed to be used. So here we expect that error message is always provided with an error text field. It can be undefined, that's fine, then we'll probably render some default message, but it must be present. And if we try to use it without passing this prop, well, we get a TypeScript error. And I think it's good when we are intentional. So here we can even pass undefined. Let's say we got this data from the backend, like error text came from the error that we got, and it might be undefined. Why not? Then we'll just render, as I said, the default message of an error. So when to use what? Probably I would just suggest use common sense. Does it make sense for a component to be used without a prop? In my error example, I imagine that it probably didn't make sense to not pass the text of an error. But maybe in your case, in your application, it makes sense. So use common sense. If you always must pass the value there and you will just expect that sometimes it's going to be undefined, then use the union. Otherwise, use optional type if you're fine with not having the value passed at all. Next one, sloppy condition checks. And we have a question. Can you please suggest when to create an interface or a type? I see both provide same benefits. They're not exactly the same. They're very, very similar in their... The difference is subtle. As it's written in TypeScript documentation, interfaces are quicker and they provide better merging. So when you have a bunch of... When you use extend syntax, when you create a base interface and then you have a bunch of child interfaces that extend it, you will get better merges and better conflict resolution where you have name clashes of your fields. You won't get it with types and when you use unions or intersection types. Another thing is that interfaces are quicker, and on most projects I would say it probably does not really matter, but sometimes it might become a problem where just compiling your TypeScript, performing all the type checks takes so much time that you sort of feel stuck the whole day you work with that project because it's constantly just compiling, and you don't even see your types updated. I don't know if you you've experienced that. I definitely had this on some projects. I would say it's quite rare. But one of the reasons might be that you're using some very, very heavy types, and interfaces are more lightweight. So one of the suggestions that I saw somewhere is just use interfaces until you have to use types. Interfaces are no longer quicker. That was a bug in the compiler. Awesome. That's perfect. Then there are, I guess then there is only one valid reason. Probably if you want better merging of different types using interfaces, using the extend syntax, or just defining multiple interfaces with the same name. Again, it's very hard to give any good advice here, because let's say this year I give you this advice. In a couple of years, maybe even less, someone will come to watch it for a suggestion what to use, interfaces or types, and then it's going to be outdated as well. Yeah, thank you for this update that interfaces are no longer quicker. I actually had no idea. I must check it myself as well and see this update. Yeah, it's very hard to give advice on this kind of thing. I think originally they were intended as different things, but as TypeScript was being developed, they just added more and more functionality, and now they can even be used interchangeably sometimes. You can create union types or intersection types from interfaces. Another question, should you use prop types with TypeScript? It really depends. If it's a client application, then I would say, yeah, probably not. There is no point. But if you're developing a library, then it might be a good idea because TypeScript works only in TypeScript environment. And what if your library is being used in JavaScript environment? So if you want your clients, people who will consume your library, to have some type checking benefits, runtime type checking in case of prop types, then yeah, it's a good idea to combine and have both types for TypeScript and prop types. All right, let's move on to sloppy condition checks. So in JavaScript and TypeScript, it's very easy to check the value as if it was Boolean. You're probably familiar with this kind of code. Let's say we have a function get message text that gets message amount that can be a number or it can be undefined. Let's say we also don't know where it comes from, and for some reason we might get, well, let's say we get an error from the back and then message amount will be irrelevant. It's going to be undefined. Now we check if message amount, then we render you have and then message amount new messages. Otherwise, we return error could not retrieve the amount of messages. What is wrong with this code? What do you think, what kind of bug will we have here that you can see? Please let me know in the comments, what kind of error do you expect here? So we have a function that receives message amount that can be a number or undefined. We check if we got message amount, then we render this text. You have, not render, we return this text. You have message amount new messages. Otherwise, we show the error message. All right, yep. Message amount can be 0, exactly. If we try to pass 0 here, it's also a faulty value, falsy value, and we'll get an error. Could not retrieve the amount of messages. How can we fix it? By being more specific with our checks. If we check that message amount is not undefined, then we can make it work properly. Now we pass 0 to this function, and then we have 0 new messages. So why do we do it then? Why do we use this, I don't know, shortcut? Well, probably that's because we sort of grew so confident that null and undefined are falsy, and sometimes it definitely happened to me a couple of times where I just was converting it to false or some Boolean type in my head and expecting, yeah, that's fine, that's going to be a falsy value, that's truthy value. And then you expect them, sort of treat them as Booleans. So that's kind of just a bad habit, bad thinking habit. And thinking what do we actually want to check just requires more effort. So the suggestion here would be to not make shortcuts, I guess. That's unfortunately kind of hard to implement, I guess. Another version of the same mistake is manually converting a non-Boolean value to a Boolean using double exclamation mark. So we sort of negate it once, and then and then we negate it twice. So first time we revert it. So if message amount was, for example, 100, then not message amount was false, and then another not message amount became true. So we sort of do the same mistake, just more elaborate. And main idea is just be intentional with your conditionals. Don't convert types blindly. I know that it can be very, very tempting to just assume in your head, to just assume that something is just the same as Boolean. Let's treat it as Boolean. And in some project, it even makes sense to distinguish between null and undefined. So null is when value was defined, but then it just became sort of null, void, it lost the value. Or it can be undefined when it never was even assigned to that field. Sloppy data modeling. Oh, and we have a couple comments. Yeah, that definitely can happen with empty string, and JavaScript sort of spoiled us, I would say. We expect things to convert from one type to another too easily. But let's continue. So what about poor data or domain modeling? Let's say we have a product. Again, we're making an online store. We have products. They can be digital or they can be physical. Physical or digital for the type field. They can have weight or they can have size in megabytes. Of course, you assume that if it's a physical product, then it will have weight in kilograms, or if it's a digital product, then it will have size in megabytes. And this is why both of them are defined as optional, because in case of digital, we're only going to use size, and with physical, only weight. Is it a good idea? Not really. Let's say we have this physical product, and let's say we have a digital. We can end up with a type, sort of our type permits a situation where we have digital product with both size and weight, or physical with both fields, or physical with weight in kilograms. That doesn't make much sense. So what we should do instead is properly model our domain. So we have abstract product that can have all of those values. It must have an ID, it must have display name, it might be digital, it might be physical, but then we define concrete, specific interfaces, digital product and physical product. Digital product will have type digital and size in megabytes will be, and it will have size in megabytes. With physical products, we don't expect it to have size in megabytes. It must have weight in kilograms. You can go one step further and define the actual product type that you're going to be using as a union between digital product and physical product interfaces. And back to the topic of what you should be using, interfaces or types, here you can see that we have digital product defined as an interface, physical product an interface, and then product type as a union between those two. And we define it as a type alias. Now we can define a product constant of type product, and if we try to fill it in improperly, for example, we have digital product with display name the matrix, and we try to assign weight in kilograms to it, then we'll get a type error. So why do we do this? Why do we just don't spend enough effort modeling our domain area? That's probably because marking properties as optional is just easier. It's another shortcut that is very, very tempting to do. And you need to know the domain well enough to write good types for it. And sometimes you're in a rush. Sometimes it's already there and you don't see any point in rewriting it. But it can really be worth it. It can really be worth, after you gain some knowledge, after you worked with the domain long enough, maybe in a couple of months working with it, you understand better the connection between different types on your project. It's a good idea to start rewriting it the more understanding you gain about the project. This way, not only you will get better type checks, but your types will also provide you with more and better information about your project. TypeScript will become more helpful, suggestive about what you can and cannot do with your data. And it's going to be easier to understand both to you in the future or some new engineer who is going to be just starting to work on the project, just a new joiner. So it's going to be easier to onboard new people. Next thing, one-letter generics or one-letter type arguments. We have a question from Amir. Hi Maxim, what about anonymous object types? Using inline syntax instead of defining a type or an interface name, is this a bad practice? You mean relying on TypeScript type inference, right? When you just define an object. Let's just look at the TypeScript playground for that one. So you mean, as I understood you, so we have some object. Let's call it a product. And instead of defining a proper type, we say that it's going to have name, some product ID, some ID or whatnot, and so on. Maybe it has size in megabytes. Did I understand you correctly? If you mean that it really depends on the project. Probably if it's a big project, not something small that you're just gonna throw away, then it's better at some point to define the types clearly. It can serve as sort of documentation. You know, like people say that types or that tests can be used as documentation. I think it's similar with the types. With good types, they provide you additional knowledge about about the structure of your data. So yeah, let me know if I understood correctly what you meant here. I would suggest to not rely too much on it. If it's okay, how to give a proper suggestion here. If it's a transient thing, if you're not gonna be relying on this data structure in any other areas of your app, yeah, why not rely on type inference? But if it is something that is part of your business logic, if it should be part of the language, okay, I'm probably up to something. So if some type is sort of being mentioned even outside of the dev team, like you have products, for example, or you have users, or you have something else, probably it's worth modeling. Probably it's not worth just having them defined as object and then using type of product. Probably it's better to define a proper type for them. That's going to be my answer for now. But let's get back to one-letter generics. What's wrong with those? Unfortunately, they're super, super common. One of the first things that people learn about the code style and clean code is to not use one-letter variable names. Probably, again, if it's something transient, then maybe I wouldn't frown too much on that. But it's so much easier to read when you give variables proper names. And I think now it's common understanding, like we're on the same page with almost every developer, that one variable names are kind of bad. We shouldn't use them. We should use proper names for the variables. The reason for that is that one-letter variables lack contextual information. You write the code once, and then you have to read it several times. Your colleagues have to read it, and you have to come back to it after a while. And then lack of this contextual information will just add more work to you. So instead of spending few extra seconds to think what is the proper name for this variable, you will have to spend possibly half an hour, couple of hours trying to figure out what is this, what is V, what is P, what is X, what is C, some one-letter variable name. Biggest problem is that, yeah, you can lose all the contextual information. It can happen quite quickly. You didn't touch part of your code base for a while, maybe for a month. Then you come back and then, all right, what do we have here? We have type T. Here it's actually, here we come to the generics. For some reason, even though I believe that there is no difference between type variables and regular variables in terms of preserving the context, reading them, it's still code. It still must convey some meaning, and using proper name for type variables, just like for regular variables, will make it easier to read them. So here in this example, we have method head that takes first element of the array. We don't know at the point of defining this function what kind of arrays do we want to work with, and we really don't care. We just want to work with any kind of array. This is why we have this type argument. Whatever it is going to be an array of type t. With one type variable, it's kind of fine. There is not much happening here. You can easily deduce that, yeah, with this t, we probably mean that it's a type of an element of this array. Imagine that it's 3, 4, 5, 10 the type variables. It can happen with complex types where you, for example, iterate over fields of other types, and then there are loops inside of loops. It can be quite complex. So it's really a good idea to start treating them just like regular variables and provide them with readable names that convey some meaning. So here, it's kind of abstract function that just works with elements of the array. So we just call it an element. Here you might argue that, all right, element is kind of looking like a regular type here, or maybe even a class name. There is some confusion. So what could you do instead? You can invent some sort of convention that, for example, for type variables, you add capital T before them. It doesn't really matter. I think such conventions used to exist for C#. And if anyone worked with C#, let me know. I think there is something like, if it's an interface, you add capital I. If it's a type variable, you add T, and so on. I think some languages use that convention. And I believe it's not part of the language, it's just part of the culture around that language. So yeah, why not do this with TypeScript and promote this idea that type variables are sort of similar to regular ones, and you can and will benefit from calling them legibly, properly, trying to convey some information, help you in the future, or some person who is going to work with this code. Yeah, let me know what you think about one-letter type variables. I think sometimes it's not that generics are hard. It's just how we write them with those one-letter variables, type variables, that make it hard to read. So why we do it? The main reason, I think, is that actually the official TypeScript docs, and I think, unfortunately, still it's the majority of the libraries, they use one-letter type variables. I don't know why. I don't know why that happened, but I think it promotes continuous use of these one-letter variables, because people open standard libraries like DOM DTS. You saw that element was just E. Type was called just E. So you look for an example, you open standard library, you see that the type is just one letter, and you're like, yeah, this is how it's done. I'm just going to be using one-letter type variables in my code. So type variables are variables like any other variables. One-letter variable names are harder to decipher. You lose the context information, and you have to read the surrounding code to understand what does this variable mean, instead of just reading the name and sort of having some idea of what it's doing. Hello, everyone who joined. What about I in for loop? Isn't E convention? So about variables in the loop, I think if it's a common with variables in the loop, I think it is a convention, and I think it's fine when everyone expects it. But in any other place, just use a legible variable name. I think it only applies to the variables in the loop. I, K, J, when you use for loops. But when you use map, for example, there is no reason to use one-letter variable. Or when you use for each method on array in JavaScript, also it's better to use a bigger and more understandable name. All right, not strict config. The level of TypeScript strictness can vary greatly depending on how you configure it, and this is good. This is really, really helpful when you migrate from JavaScript to TypeScript, you want to be able to configure this strictness. But generally, when we are sort of established and we already work on a TypeScript project, we want it the strictest setup possible. The more issues TypeScript can catch compile time, the less we'll have to worry about bugs in our applications. It doesn't catch all the bugs, but it prevents a lot of them. As an experiment, I started to work on JavaScript code base, and well, I miss TypeScript. I really miss TypeScript. I think it gives you this sense of safety, certainty, confidence when working with code, when you change it. It also allows you to get understanding of the project structure better, what kind of data do we operate with, and so on. The project becomes more discoverable when you work with the code. Anyway, that's about strictness. So the first option I recommend you enable when you configure your project is the strict mode. This option will enable a set of checks for your code. Depending on TypeScript version, it will be a different list. Generally, it's stuff that has strict prefix in it, but that's not all of them. Some of them don't have this prefix. So for example, one of the options is always strict. It enables the strict mode. It actually affects the outputted JavaScript. It doesn't affect the type checks, but it's still a good idea because then you will have more runtime checks and JavaScript execution will become sort of stricter. Then strict null checks. When strict null checks is false, null and undefined are basically just ignored. So for example, here we're finding a user in an array of users. Here it has 2 by comparing the name. And as you might guess, logged in user might be undefined. We might not find the user. We have user 1, user 2, and we try to find one with a name test. We might not find it. It might be undefined. But when we try to do logged in user.name, it's going to be okay. TypeScript without this setting will allow us to do this. And it's bad. So definitely turn this setting on. It is called strict null checks. Next one is strict bind call apply or bind. Yeah, and it just makes TypeScript check that arguments that you pass to bind call or apply match the ones that you defined in the as arguments of your function. I think it's a bit strange that by default TypeScript doesn't check that. I would definitely expect that to be checked, but well, it's good that we can enable it. So definitely enable this one, either individually or by just enabling strict mode. And there are more, there are others. If we open TypeScript documentation, I think it's better to open it in a separate tab. There is a whole list of different flags that you can enable. Here is the description of the strict with the list. I think it's currently stored for, I'm not sure if it's for a specific version. All right, it's for version 2.3. You can check what each of the options mean, what it does. They have nice examples showing you what will be the difference between the setting on or off. So definitely worth checking. And also when you create a new project and when you generate tsconfig using tsc-init, you will actually get a good list of options. Strict, I think, is enabled by default, and then you have a bunch of commented lines, which you can gradually uncomment. I think I would enable all of them. There are some good ones that work better than ESLint configuration. For example, checking for unused variables, checking for dead code. I think TypeScript does it better, so I prefer that. And the last one, not updating TypeScript compiler frequently enough. So with each version, TypeScript brings more great features. Like, it's one of the projects where I'm genuinely happy to see a new version. TypeScript 1.6 introduced TSX file extensions and enabled us to write JSX code. This was the time where TypeScript developers switched to as instead of angle brackets for the type assertion. TypeScript version 2 added optional null checks. TypeScript 2.3 enabled generators and iterators. TypeScript 3 brought tuples and rest and spread parameters. TypeScript 4 added more functionality to the tuples. It added template literal types. It's actually another topic. Once I accidentally discovered it trying to compare literal template string literal with a regular string, and they did not match. That was a big surprise to me. But each new version brings more and more features, more configurations and bug fixes that allow you to be more expressive and be more describe the reality of the types of your application better. It provides you with better language with every version. So potentially, I would even create having the time for that. I would probably even set up CI that would pull new TypeScript version every now and then to verify that your project is not going to be broken. So you kind of can adapt and prepare in advance when you want to migrate to newer version, and then do it regularly. And that's it. Thank you for watching. Thank you, Renato. All right, I think we can hang out a little bit more, a few more minutes if you have questions. Thank you, Robert. Thank you, Align. All right. Thanks, everyone. Have a great time of the day, rest of the week, and goodbye.